All right, so numbers 13 to 15 and 17. Those of you that took Physics 12, you could do 16. I didn't assign it because I was worried of those of you that are only in Physics 12 now. There's F equals KQQ over R squared and FC equals MV squared over R. There's a few of the Physics 12 equations in there, and I just didn't want you to panic. So that's why I skipped it. Number 13, what is the difference between the energies of the E4 and E1 level of hydrogen? So it doesn't say which way it's going, but I'm going to assume E4 is the initial and E1 is the final, simply because that was the order they put them in. So going back to the other day, you found E1, or it's negative, or at least you can find it now, negative 13.6 electron volts divided by 1 squared is about negative 13.6. And E4 was, I think, the point 855? Yeah, negative 0.85, not only 1.5. And so we get an EP of 12, right? Yeah, negative 12.75. Sorry. People are dinging me. I'm distracted. And if it is indeed going from 4 to 1, then this would be negative. If you did 1 to 4, it'd be positive. One way it's emitted, the other way it's absorbed. Okay, so that's number 13. Then number 14 says, from what energy level did an electron fall? Oh no, I missed one. Number 14. By what amount does the mass of a hydrogen atom decrease when its electron makes the transition down from 4 to 1? So it really was going down. So now you might think you don't know how to do this, but this energy that's being given off, thanks to someone that you may have heard of called Einstein, we know energy is equal to m times c squared. So every packet of energy can be, you can figure out how much mass that would be. And every particle of mass, you could figure out if that all turned into energy, how much it would be. So here they're just saying, like, if this energy that's being given off, how much mass would that have been in the electron? So you just take your 12.75 electron volts, of course, multiplying it by 1.602, to the negative 19 joules per electron volt, and then divide it by the 2.9979 to the 8th meters per second to convert that energy into mass. And look at that, your first time using E equals mc squared, and you get 2.27268 times 10 to the negative 35 kilograms. So it's not a very big amount. We will come back and use this equation for real in nuclear, but the textbook strikes again and drops it in here early, just because it liked to, I guess. All right, number 15 now. It says, from what energy level did an electron fall if it emits a photon of 9.38 times 10 to the negative 8 meters wavelength when it reaches the ground state? All right. So this one's actually quite a cool question, and it would be one that if we were in class, I would give you more of these. Okay, so it's telling me the wavelength of the photon is 9.38 times 10 to the negative 8 meters. So of course from that I can find its frequency by doing c divided by lambda. So 2.9979 times 10 to the 8th meters per second divided by this 9.38 to the negative 8 meters. And I get a frequency of the photon to be 3.196 to the 14th hertz. And then from that I can get my EP, because EP is just equal to HF. So 6.626 to the negative 34 joules seconds, 3.196 to the 14th hertz, and I get an energy of my photon to be 2.1177 to the negative 18th joules. But now it's talking about falling up or falling down in a hydrogen atom. I'm going to need to convert this 2 electron volts. So divide by 1.602 to the negative 19 joules per electron volt. And when I do, I get an EP of 13.219 electron volts. Okay? And it's saying, and it's falling down, so this is being emitted. And that's going to become important when I go to the next step. Because it says what level did it fall from? So we're doing EP is equal to E final minus E initial. We're looking for the E initial where it fell from. So E initial will equal E final minus EP. And it says it's in the ground state. So 13.6, and that's a negative electron volts, is the ground state in hydrogen, right? The N equals 1, minus a negative, and it has to go in as negative because it's being emitted, 13.219 electron volts. Otherwise, you'll end up with like 26, and it'll be way too big. So EI is 380,859, and it's negative, okay? So that's the level, that's the energy. But it wants to know what the level is. So now we go to, come on, you can focus. Come on. Oh, wait, if I tap the screen instead of the paper, there we go. So now we go to En is equal to negative 13.6 electron volts over N squared, and we solve for N squared. So negative 13.6 electron volts over E that we just found. Okay, so, whoops, N squared is equal to negative 13.6 electron volts over negative 0.380859. And when you do that, you get, did I write it down? Yeah, 35.7087, etc. And then take the square root and you get 5.976. Your book was looking for N equals 6. Okay, so that's number 15. Number 16 says, no, 16 we skipped. Number 17, hydrogen atom has an electron in the N equals 2 level. If a photon with a wavelength of 332 nanometers strikes the atom, show that the atom will be ionized. Okay, so N equals 2 level, which of course E2 is equal to 13.6 electron volts negative over 2 squared, which if you had already, but negative 3.5 electron volts. Oh, it's 3.4 though, not 3.5. Okay, and then it says the wavelength of the photon is 332 nanometers. So we can get our frequency, C over lambda, and we get a frequency of 90298 times 10 to the 14th, and I'm just going to do this quick so we don't run out of time. And then from that we can get our EP, which is equal to HF, and it's 5.983 times 10 to the negative 19 joules, which you have to change to electron volts, so 3.7348. Now, so this is a 4, this is how much energy it needs to obtain to be ionized, and this is how much the photon has. So part A, yes, it'll be ionized. What will be the kinetic energy left over? Go back to EK max equals HF minus WO. So EK max is equal to the HF, the energy of the photon, 3.7348 electron volts, the WO, this 3.4, and the energy that is left over is going to be 0.3348 electron volts. I think the question might ask for it in joules. So switch it to joules by multiplying by 1.602 and get 5.3636 times 10 to the negative 20 joules. All right? Hopefully these are doing okay with you. Very good.